So, and we all see that we already studied the four atomic models, actually, sorry, three atomic models. What is the first three atomic models we have studied already? First one is J.J. Thomson model. Second one is what? Rutherford
Both.
atomic model. And what is the third one, everybody?
Both.
Bohr's atomic model. Yeah. Now, Bohr's atomic model, okay. Bohr's atomic model, we studied that names of the cells and what is the cells, number of electrons also I have taught you. So can you tell me what is the different cells of an electrons we have studied in Bohr's model? Yes, please. Mute yourself. Yeah, what is the cells we studied in Bohr's model? As we all know, electrons are arranged in a circular orbits around the electrons. What is the names of the cells? Bohr's model. Remember and tell me.
AL.
Mari? Yes, please. What are the names of the cell? First, nucleus. Protons and neutrons are there. Next cell, the cell which is
K.
closer to the nucleus, K. Next is L. Next is
H.
M. And the next cell is a what? N.
N shell.
So that is what. So remember, the cells, the energy order also. Sir, which cell is greater energy? I am saying you now. So please note that. The energy order, already I taught you, but again I am teaching. So energy order, check your classworks and tell me anybody have written or not. So K is less than, L is less than, M is less than N. Check it, everybody, verify it. You have done or not? All of you.
Yes, sir.
So which cell is maximum energy? Which cell is maximum energy? Valence cell, N cell. So the cell which is near to the nucleus, the cell which is near to the nucleus, which cell?
K.
K. Do you understand?
K.
So that is what you have to remember. And I have taught you number of electrons, arrangement of number of electrons. There is a formula. What is the formula? Anybody? What is the formula? Don't know?
2n square.
Yes, 2n square. This is only we used to call it as Bohr-Bury scheme. Bohr-Bury scheme. So it will gives us number of electrons that can be accommodated in a shell of an atom. Note it. That will gives number of electrons that can be accommodated. Can be accommodated in a shell of an atom. Clear, everybody? I hope you all understand. Everyone? So what is the formula? Bohr-Bury scheme. What is the formula, everybody? 2n square. Clear, everyone? And we all know name of the shell. Everyone? So what is the name of the shell? Please. Name of the shell. K cell, L cell, M cell, and N cell. Shell number. Shell number is what? Shell number K1, L2, M3, N4. Till now, whatever the elements are present, we are having only maximum n number of shell. Future it may come K, L, M, N, O also will go. But till now there is no, but future maybe it is. So next, maximum capacity. Already taught this, but again, maximum capacity to accommodate electrons. What is the formula? What is the formula? 2n square.
2n square.
Learn. Everybody learn 2n square. So that is what it is. So what is the name of this 2n square? Everybody? Bohr-Bury scheme. Bohr-Bury scheme. Why it is? Because it is a Bohr's only. Bohr's atomic model it is. Clear, everybody? Yes, please.
Yes, sir.
Yes. So now K is equals to N is equals to 1. So 2 into 1 square, which is equals to how many? 2. Clear, Rama? Yes. Next, 2 into 2 square, which is equals to 2 into 4, which is equals to 8. Next, 2 into 3 square, which is equals to 2 into 9, which is equals to 18. Next, 2 into 4 square, which is equals to 2 into 16, which is equals to how much, Ra? Yes,
32.
32. So that is what is the number of electrons. So number of electrons in a shell will follows 2, 8, 18, 32. That is what you have to remember. I hope you all understand. Anybody? Ma, remember, this is not the number of electrons. What is this? Maximum number of electrons you can put. Clear, everyone? This is about maximum number of electrons which we can deposit in a given shell. But every atom does not have this many. Do you remember, everybody? All of you, what I'm saying? This is the maximum accommodation. For example, in a hall, maximum 500 people can accommodate. Doesn't mean that 500 people are there. It may be 5 members also there. It may be 2 members also there. Or even people like nobody is there. Understanding? Then 10 members are there. So that is what I'm saying. So maximum capacity is different from number of electrons present. Clear? Agalya? Mari? Anything doubt? Please let me know. Understand, everybody? So maximum number of electrons we can put in a shell is, suppose I will take shell number 1. What is the shell number 1? Name it, everybody. Shell 1. Shell
K.
K shell. Okay.
Yes.
So K shell, maximum how many electrons can go? Maximum
2.
electrons. 2. But maybe one also there. Do you understand it? Maybe one electron also present. For example, I'll take hydrogen. Hydrogen, only how many electrons are there? In nucleus, one proton is there. And how many electrons is there? How many
1.
there? Only one electron. Only one electron is there. That's all. So, but how many we can accommodate? How many we can accommodate in the
2.
2? That is what. So 2n square will give you, Bose-Bury scheme will give you maximum capacity of a shell. So that is different from the number of electrons. Kavya, understand? Shivani, Sangamitrai, Alfin?
Yes, sir.
Yes. So please do it. Now I'm going to give you three statements. After this, we'll finish it and then we'll continue. Okay. So right, first point, the maximum number of electrons. First point number 1. The maximum number of electrons. The maximum number of electrons. The maximum number of electrons in different shells can be calculated by the formula. What is the formula, everybody? 2n square. Clear? Where? What do you mean by n, guys? N is equals to what? Number of shells. Understand? That is what. May either n equals to 1 or n equals to 2, n equals to 3 or n equals to 4. That's what. 1, 2, 3, you can put 4. Okay? Second point. The last shell. So now hydrogen, how many cells are there, everybody? Hydrogen, how many cells are there?
1 cell.
Then that itself a valence cell. Do you understand, everyone? Clear, everybody? All of you?
Yes, sir.
Yes. So if one cell is there, that is the valence cell. 2 cells is there, second is the valence cell. 3 cells is there, third is the valence cell. 4 cells are there, fourth is the valence cell. Is it okay, guys? Everybody? Yes? Tomorrow you'll understand. When we are drawing the atomic structures, of first 20 elements we'll draw. By the time you'll understand it. Everything. Is it okay, guys? Please respond. All of you.
Yes. Yes, sir.
Okay, that is what. So now, right, this is the most important point. Note very, 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 very important point. Entire chemistry is depending on this point only. That is what. The last shell. The last shell. See, last shell means there is no fixed number. It may be K shell, it may be L shell, it may be M shell, it may be N shell, based upon the element. So the last shell also call it as another name. I already told you. What is another name?
Valence shell.
Valence shell. Valence shell, you cannot have more than 8 electrons. You cannot have more than 8 electrons. 8 electrons. Even if it has a capacity, even if it has a capacity even if it has a capacity to accommodate more electrons. To accommodate more electrons. Do you understand, all of you, what I'm saying? Please respond. So in valence shell, maybe original maximum capacity is suppose 18. Understand? Maximum capacity is 18, but you cannot put 18 electrons in that. You can go maximum how many electrons? Only 8 electrons. Clear, everybody? That is only valency relation. We will study that. Okay, that's what. So make it next. The last point. This is also another crucial important point, right? The shells. Shells are filled. Shells are filled stepwise as electrons are not accommodated. Electrons are not accommodated in a given shell unless the inner shells are filled. Means, for example, there is a two shells. Now, without filling the K shell, electrons won't fill in the L shell. That is the meaning. Without filling the L shell, electrons won't come into the KM shell. So, without filling the inner shell, it won't come up. That is what you have to remember. Clear, everybody? All of you? Yes, please. So that is what. So this is what is about electronic configuration. Now, your duty is that go through this tabular column, which is there in our book. They have,
Can you please show this slide?
yeah, 1 minute. Yeah, please finish it. Finish it this point, then I'll continue. Do it.
Completed, sir.
Completed? That's what. Now, you all can go through your textbook. So your textbook you can see. Tomorrow I am going to explain. Your textbook they have given 20 elements in this one. Sorry, first 18 only they have given. Of course, tomorrow we are going to make 20 elements. So composition of an atom of the first 18 elements with electronic distribution. Electronic distribution only we used to call it as a what? Electron arrangement or electronic configuration. So that what is what. So you should learn. All of you understand? So valency not required. How to calculate valency I will teach you. So till here you have to go through that all the 18 elements. You have to observe. I'm not asking to learn anything. I already told you long back, learn at least 30 elements, first 30 elements. See the symbol. Hydrogen, atomic number 1, number of protons 1, number of neutrons 0. So number of electrons also 1, distribution of electrons, K shell 1. No other LMN. LMN shells are not existed in what? Hydrogen. Only one shell is existed. What is that shell? What is that shell?
K shell.
K shell. No LMN shell in hydrogen. That is what you have to remember. Clear, everybody? All of you?
Yes, sir.
Yeah, that's all. So go through that and finish it. So with this, I'll stop and we'll continue from here in our tomorrow's class. I'm expecting everybody just at least from the new year almost. This is the 5th day in new year. Take it a change. We want to work. That is what is only purpose. So please be a change always. I want it. That is then only I can push you in the next year to academic class 10th. Otherwise, it's very tough. Days are becoming very tough. Next year, 60% CBQs. So remember that and work. It's not easy at all in CBSE. Things are going to be very, very tough. So please understand that and do it. Okay. Thank you, everybody. We'll meet in tomorrow's class.